All right, everyone. Let's get the show started. Welcome to our DevOps office hours. It's March 3rd, 2021. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team while showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. We'll automatically post a video recording of this session to our YouTube channel. So if you enjoy this content and want to support our channel, please go over there to YouTube and bash those buttons to submit and subscribe. We appreciate it a great deal. We'll also follow up with an email so you can share that with your team. And with that said, let's kick it off. Got a couple announcements today. I was scratching a little bit here. I didn't have that too many things. One thing that's coming down the pipeline here is our Terraform modules for AWS RDS Proxy will be out probably in the next week or so. So expect an announcement on that next Wednesday. And we're also working on our AWS Code Deploy module so that we can use that with ECS to do blue-green deployments. That's on an active engagement we have. So expect those forthcoming. Another thing I learned this past week, and I wish I'd known about this a lot sooner, was that the AWS Nitro instances provide a lot more than added performance and reduced cost, but they also provide encryption in transit within a VPC, or at least certain instance classes do. We are still waiting on final confirmation on what those instances are, and if anybody knows for sure, they can let me know. This documentation says these are the instances that support encryption in transit within a VPC, but we've found conflicting documentation at Amazon on this, so we're waiting confirmation. What's rad about this is that it can simplify perhaps some compliance objectives. If you need to ensure you have encryption in transit, for example, for HIPAA, PCI, or high trust, you can accomplish that by deploying or redeploying your EKS node pools, for example, with these instances. That said, traffic between your ALB and NLB and these instances is still not encrypted. So you'll need to terminate TLS or re-encrypt from the load balancer to the pod service as well. Alternatively, don't use an ALB ingress controller and just use something like Nginx ingress or Envoy ingress or Istio ingress or any one of the other multitude of ingress controllers that's deployed inside the cluster and can do its own TLS, manage its own TLS. Any questions on this? Anybody using it?
I used it on GKE, and I think there was no node that couldn't support the encryption in transit. At least I don't remember.
Yeah, that's the beautiful thing with GKE is they ensure all traffic in a VPC is already
You
encrypted.
just click the option. And
Yeah, exactly. On AWS, that's left up as an exercise to the user.
yeah.
The thought that came to mind for me was, I don't need this because Istio does it for me and I use Istio, but I know not everyone does.
Yeah, and Istio, how fun is that to do major upgrades of your control plane? I mean, I don't know when you got started, but that was like Istio 1.9 just came out with the announcement that they're focusing on day two operations. But it's a classic thing. Like, yeah, really easy to get deployed. It really sucks for day two operations.
Yeah. There's also
Ask
something
me
that-
again in a year. We're running it in production right now, so
Yeah,
we
exactly.
haven't for very long.
Yeah.
I was going to say there's also something to be said about offloading it to hardware instead of doing it in software from a performance standpoint. I haven't actually seen all the benchmarks, but they actually have like they have a sub processor like in the CPU that actually does the encryption and the decryption, which should probably be significantly faster, but it depends what your scale is and all of those kinds of things as well.
And defense in depth is totally an argument for having a couple of different layers as well.
Yeah, I agree. And there's a lot of stuff you can't do with this, like mutual TLS, like between individual
inside the cluster.
Yeah, exactly. So
zero trust.
It's not saying like, hey, go throw away Istio if you're using Istio and that's working well. But hey, if you haven't crossed that chasm yet and using Istio and you need encryption in transit, well, you have a really easy, quick win. Today, you go change the instance type and bam, you have encryption in transit within a VPC, not over the transit gateway still. So just be advised. All right. So moving on to the next topic, there was there are some new there's some new features that have are upcoming in terraform-docs. One is anchors in the sections, which is nice because terraform-docs, which is what Cloud Posse uses for all of our modules. If you look at like our EKS module here, there all this documentation below here, the requirements, the providers, the modules, the resources, the inputs, the outputs, all that is automatically generated by terraform-docs. But these sections, I guess they were lacking. Well, if they were headers, they would have anchors already. So I don't remember what this anchors was with respect to. But what I learned was that I didn't know that terraform-docs had a terraform-docs YAML config. So you can now define exactly how you want your docs to look like.
I think the anchors was in reference to individual inputs or outputs.
Oh, rad. Okay, I got you. That makes sense.
I think that was what
you
RB
could
put up an issue for.
link, so you could get an anchor to the delimiter here and say, hey, look at this. Okay,
exactly.
That makes a lot of sense. I also really love this new addition where it links out to the documentation for all the resources you use in the module. Very convenient.
And then you get a quick glance of how big is the blast radius of this individual module.
Yeah, how much is it doing? In this case,
Yeah.
a heck of a lot. Yeah. All right, next one. Since last week we missed the announcement of Terraform 0.15 beta.1 by like a couple hours or by like 20 minutes, I thought, okay, I'm just going to link to it here because we are exactly at the cadence of Terraform making their big releases. So I thought here on Office Hours, we'd be the first to break it, but I guess not. So as we can see, this here was 7 days ago, and this one here was 14 days ago and 21 days ago. So I expect 15.2 to drop today, or maybe even the actual release. That'd be cool. All right, and then some filler stuff here. If you haven't already supported Cloud Posse, we really do appreciate any contribution you can do. You can head over to github.com/sponsors/Cloud Posse for as little as $1 a month. You can help pay our GitHub costs and stuff like that. Really appreciate it. We spent a couple $100 on GitHub, a couple $100 on Renovate Bot, for example, so it helps. What else? And our YouTube channel. Definitely do check out our YouTube channel for all the past recordings. Head over to youtube.com/c/Cloud Posse to catch up on all the old Office Hours recordings. All right, let's get to business. Talking points. Lots of really interesting questions came up in the Office Hours channel over this week, so I want to get to those today. The first one was asked by Marcin, who's on the call here. Let me read his question here and tee it up so we can talk about this some more. So in the Office Hours channel here, if you haven't yet joined our Slack team, head over to slack.cloudposse.com, slack.cloudposse.com, and that's where this conversation is happening here. All right. So Marcin is asking, wondering if somebody's already done this. What are some solutions that exist today for disaster recovery, active-active Kubernetes clusters, where traffic can be partially switched over and ensure security at a granular pod level? Some solutions out there that he's seen for this is like Portworx has something. This is really the category of what the service mesh offerings provide. If we're talking about some of the commercial ones like the console service mesh, this is what you get when you go to the enterprise tiers of it. If we're talking about vanilla Kubernetes, you have federated Kubernetes where you can have a network that spans the clusters, but that still doesn't help with encryption. So it comes down to the service mesh that you're using. Martin, since you're on the call, do you want to add additional context to the use case, the problem that you have, and what you're doing today?
So I was wondering the networking between the Kubernetes clusters had to be some kind of mesh. This is what I get. But I'm thinking who should be responsible for switching the traffic?
Yeah.
It should be something outside of both clusters, right?
Well, we're talking active here. So I don't think that it's a person that makes that. I think it's based on the health and the routing setup that you would have. I argue, though, that let's talk about active first of all, and it means different things to different people. Let's talk about what some of the design patterns are for active. And this is one pattern where you're solving it at the control plane layer, kind of, or your shared platform layer. But there's another way it can be done as well. So for the shared platform here, we're talking, you have Kubernetes cluster, let's say in the East Coast, Kubernetes cluster on the West Coast, or let's say you're both, for performance reasons, they're just in two different regions on the East Coast. So East 1, East 2, for example. We could set up a service mesh that connects those two clusters, and the services are able to discover each other based on facilities of the service mesh. Mostly it's DNS based usually. In this scenario, it's simpler from the deployment perspective that, hey, we just deploy something to one of these clusters or both of these clusters, and the failover mechanisms we have in place, which I'm just hand waving here. Let's just assume those are going to work fine. But it introduces a lot of other concerns and complexity about tenancy, latency, database connections and performance, IAM considerations between these two regions, DNS, etc. I think few companies manage the sophistication of an architecture like that attend my office hours. Those are companies like a Netflix that have had to figure it out as a necessity. I think there's a simpler way possibly for companies to also think about active, and that is do it at a layer outside of the cluster itself. So things aren't moving between pods are not moving between clusters. Clusters are totally disjoint. Clusters provide a service. Think of the cluster as itself almost as a pod in itself. And then you have another cluster that provides the same capabilities. And then you have your CDN layer or your WAF layer that is responsible for routing traffic to both of those clusters. And then you have other considerations as well as how you're doing active. Is it based on sharding? Can you have tenants? Can you have different tenants in different clusters? So in an outage situation, some percentage of your customers are offline, but not everyone is offline. Do you have a way to migrate customers or tenants from one cluster to another cluster that you're solving that way? What I like about this is architecturally, it's rather simple because you're still thinking about just this cluster, you're still thinking about this cluster, and you're just thinking about how you're sending traffic between them.
Yeah.
Vlad posted a YouTube video from AWS reInvent. I had the same thought to post something up from like one of the KubeCons, because this is something that's hot topic, when it comes to doing KubeCon talks. I know like the last KubeCon I went to was, before COVID, 2019 or whatever, but like Uber did a great one, on how they do this kind of stuff. Well, I would definitely peruse YouTube for a little bit, try to find, go find Uber's talk. They do one every KubeCon. Like they're Kubernetes masters over there. Yeah.
Yeah.
Anyone on the call have some solution in place for that?
Yeah. Anyone doing it? Yeah.
I designed and implemented and ran a bunch of multi-region, including active applications in production. It's a huge pain, first of all, and I highly recommend you watch the YouTube video from reInvent. I posted it both in the Zoom chat and in the thread on Slack. You're also mentioning two things there: disaster recovery and active. Those are not necessarily paired together, because yes, you can do disaster recovery in an active scenario. I'm not denying that, but you can do disaster recovery without active, which is something that is extremely complex to do. It is super hard, and yeah, at Uber scale, it makes sense. I'm not Uber. I'm cool, but I'm not Uber levels of cool. And your application is not just Kubernetes. It's not just containers. It's not just pods. Your application is IAM roles. Your application is VPCs. Your application is probably ECR repositories. Your application is
RDS.
Cognito and Kinesis. Even if by some miracle you re-implement all that in Kubernetes yourself, which would really be a miracle, but I'm not going to go into that. Even if you do that, you still have a bunch of dependencies. And yeah, the way to do it is at a higher level than Kubernetes through some routing, either at CDN, either doing Lambda at edge, either with Route 53 health checks and latency routing and things like that. All of these are better explained, way better than I can explain them in the YouTube video that I linked. So I highly recommend you go check that out. For Kubernetes itself, there are options. There are specifically disaster recovery options, like what was it, Heptio's Arc, that got renamed into something else, that can back up thing in your clusters, and then you can configure those backups to go from your region to another region. But that's gonna have relatively high MTTR time, so it's gonna take a while for you to recover. Not ideal. You're mentioning active, so I imagine you want something very tiny there. And again, it gets super weird, and it's very well explained in the YouTube video.
A mentor much smarter than myself once told me, and he was talking about people that want cross cloud, but I think it follows under the same category. And he said there's only two reasons why you would do it. Either you lose more money than you would spend when you have downtime. So like if you're losing tens of millions of dollars a minute, if you're Amazon or something, or if people will literally die if the service goes down. Like those are the only two times that we're ever going to do something like this.
Yeah, nowadays it's really easy to lose millions of dollars in a minute downtime.
Yeah, for sure. I heard recently a story from one of our customers that was similar to this. They were down for 4 hours and lost a lot.
Yeah, I can go bankrupt after 4 hours of.
Yeah, or an HFT that can't exit the market.
Yeah, I had a customer one time who was a company that serviced airlines with their food. And they actually told us that they lost something like $250,000 a minute for every minute that they couldn't put like food on planes, basically. So if their systems that controlled all that went down, it was,
wow.
It was pretty expensive.
But I mean, you're getting up into Uber scale type stuff, right?
Yeah.
Like you've got teams of DevOps, people working on it.
Yeah, serious systems architecture engineering.
But getting back to the question, we have right now in place, we have DNS solution, which is outside of the cluster. So we don't know any internals of the cluster. And right now, if we expose it, like literally anything can connect to it from our cluster because this is how it works, right? It's on a network level. And I'm not sure how to follow that and restrict, and if it's even possible with that approach.
Yeah, so like partially degraded scenarios where it's not black and white whether or not to send traffic or not to this cluster. I think that's really difficult to ascertain, and there is no generic answer to it.
The sadness on the call.
Yeah. I want to have the silver bullet for this one, but I expect as much. Well, let's unless there's some other point to add to that, let's move on to the next question.
Thank you all for answering the question.
Thank you for asking the hard questions, Martin.
Have some YouTube videos to watch.
Yeah.
Hey, Eric, one thing comes to mind when you mentioned high frequency trading. I had built and ran an early high frequency trading routing system. And well, you guys will appreciate that. It was a JavaScript layer on top of a Java engine. And the way they built it, every single transaction was not just transaction, but message back and forth was persisted in memory. That just completely killed me twice. They didn't figure it out till the second time. I got fired over it. But in terms of, so it's worth mentioning this. What I learned was that if I had some good reporting and I could hand over to my manual traders what my position was, they could have traded out of that, to your earlier point. But that brings it, that's just to mention a larger issue of it's not always a technological solution.
Yeah. I like that. And it's what you're saying is you can use active-active as your, for agility, but also for DR. But maybe you need a DR strategy when even active-active isn't enough. And how are you going to back yourself out when all that technology that you had invested to support active-active fails you? Well, maybe you just need that simple report to get you out of the situation. To bring up an analog.
Surprise when I learned that $40,000 and a job later.
Yeah. Sorry, you had to learn that the hard way. That's my life in general. There's no shortcut for hard lessons learned. All right, let's cover the next question here, Mohammed. You were asking for Terraform testing locally. What are your thoughts or experience? There's LocalStack and Moto. Question for you there, Mohammed. Are you saying like testing while you're doing development or actually writing tests, or both?
Yeah, I think both, but we can cover the unit testing and integration testing phase and also the end-to-end testing phase.
Mm-hmm.
So yeah, I see a lot of hype around LocalStack and the Moto, the open source alternative for LocalStack, but I want to know if anyone tests this or use it for testing, because I think it's gonna be really helpful with the testing, phases.
I can probably provide a little insight here. So in my former life, prior to joining Cloud Posse here, I was one of the maintainers of TerraTest and one of the original authors there. And I can say that we looked at a number of alternatives for doing this and speeding up the cycles of being able to do testing while doing Terraform module development. And generally found that no matter what we had that was mocking endpoints was not sufficient enough to do true Terraform testing, because you end up having to do a bunch of different things, and then at the end of the day, all you get is successful. All you get is that your Terraform successfully ran. You can't actually like verify that, you know, it really did what you wanted it to do on the cloud. And it didn't prove all that useful in those testing scenarios for us. That an API, you know, level call succeeded, which we sort of already take it for granted that Terraform providers themselves are tested and work. So all we're doing is sort of exercising that again by running it against a mock rather than against a real, you know, a real AWS account or whatever you want to look at it from that perspective. So I didn't particularly find it very useful and couldn't justify the overhead of making it work and doing all the hurdles and things that we needed to do to make it work. And it also doesn't have full AWS support, and it's always behind where AWS APIs are. So
let's qualify this there, or let's reframe it then based on some more information. So Mohammed, what are you trying to solve with something like LocalStack or Moto? Why not just use straight up Amazon testing account? What are you solving?
I think the offline testing phase is now part of test-driven development. So it's called offline API testing. Yeah. So that's been a lot of attention recently with test-driven development for Terraform. So I want to see if covering the case, and also for Matt, I agree with him. But now these LocalStack and Moto, even LocalStack has a paid version, by the way. So it has a lot of supported services on AWS.
Yeah, so, admittedly, I'm talking about a little while ago when the last time I looked at it was, for sure.
Yeah, I bring this point because there is a lot of updates on these two projects, and a lot of people now moving to a better, answering your question, Eric, a better cheap alternative offline, you know, more speed, more quicker, a more cheap option than testing on real environment. I agree with you, real environment, no one can beat that. But you still need a cheap and fast alternative.
Yes. So the reason why I asked, go on.
In a real environment, you can test cheaply by using Fisher flag and testing in production. And that's the bleeding edge if you want to code it. So there are options.
Yeah. So there's that. So it has come up before, and just to mention that, I mean, sometimes the reason is to save money, and that was mentioned here. And I really don't think in the long run you're going to be saving money as a company doing it because of the cost of engineering effort to maintain it and work around things when it doesn't work. And you're still, like to Matt's point, still not testing the real thing. I also think that it's just one small area. Are you just doing AWS, or are you using AWS, Cloudflare, Datadog, OpsGenie, or other SaaS things? And how are you testing that? And like, do you really want to solve something that you can only solve like 20% for offline, and then or maybe 80%, but then you still have all this other critical stuff that can't be tested using offline mechanisms? So I think it's optimizing for the wrong thing. Why optimize for offline when everything you're doing is online?
So one of the things, the DoD gets a lot of things wrong when it comes to DevOps, but one of the things they get right is they use, like the Navy uses what they call a digital twin. Because you can't have a battleship in a developer's office, right? But they do, and so they do a digital twin. And with infrastructure as code, like with IAC, it seems like the digital twin should just literally be an exact copy in another account, because you can totally do that. You can't have a battleship in a developer's office, but you can spin up another account.
You can.
And so that would be my.
For the record, things like LocalStack specifically is awesome, but it's still limited. I remember trying 6 months ago to use it with serverless projects to do local development, and it was a pain. Like it covers a lot of AWS, but it's never going to cover everything. And it is very, very, very annoying when you have a bug locally and it works in AWS, or when something doesn't work locally or works in AWS or the other way around. It is very, very annoying. And a lot of dev cycle and a lot of money is being spent on this. So this needs to be looked at from a business perspective. What are we optimizing for? Okay, we don't want to do full end-to-end Terraform testing because that takes, I don't know, 1 hour and a bunch of money for creating a bunch of services. That's annoying. Okay, what do you optimize for? Do we need that level of testing? Or do you want to spend that money and have the dev wait for 3 hours for a test to run? Because that's something that's also terrible. And there are different layers because not everybody needs 100% test coverage and 100% availability and 100% everything. It is a very, very, very expensive proposition.
Yeah. Well summarized there, Vlad. Let's move on to the next question or topic here. Since we have Matt Calhoun on the call, oops, I called out the wrong Matt here. Since we have Matt Calhoun on the call, let's talk about this one.
You might have called out the right Matt. Who asked the question?
Oh,
I asked
you're
the
right.
question.
Dude,
But I think it's reasonable because Calhoun, you're implementing you're implementing a bunch of the security modules. So I think that it makes sense
I'll
to get
answer the
confused there.
question.
That's so funny.
You
Well,
asked
yeah,
the question,
let me set it up. Let me set it up, and then we'll get into it. All right. All right. So Matt Gowie asks Matt Calhoun. It would be great to chat about rolling out GuardDuty using some of the Cloud Posse tooling. We have a lot of this covered by our Terraform modules, including our Terraform AWS GuardDuty module. We also have our CLI tool called Turf. So Matt, Calhoun, can you lay out the landscape here so Matt Gowie can understand how the relationship between these tools?
Yeah. So basically, there's a central GuardDuty account in region for your entire AWS organization. That thing should basically be deployed with the Terraform module and configured how you want it configured. And then you basically use the Turf CLI tool to enable GuardDuty and point at that central account and region for every other account and region that's within your AWS organization. And rather than writing, first GuardDuty doesn't have a Terraform way to turn all these things on. So that's why we went with a CLI that calls the AWS API directly so that it goes along and does that. So there's your command right there, Eric, the Turf AWS GuardDuty set administrator account. You give it a role that has the ability to run in that account. And then you need also another role that can talk to the root account of the organization so that it can set the flag at the organization level to say the security account in this case is the GuardDuty administrator account for the entire organization. And then you set the region where you want that to run, and this thing goes through your entire AWS organization and turns that on for you and points it at that account.
So Matt, you touched on it briefly there, but can you just emphasize again, like what is covered by Terraform and what is not, and if there's any nuances between deploying GuardDuty before you deploy your member accounts and deploying GuardDuty after you've already provisioned member accounts? Are there any nuances there?
There aren't for GuardDuty. There are for other components.
Oh, okay.
Yeah. So the thing the GuardDuty administrator account is the name of the master account for GuardDuty, whatever you want to call it, within your AWS organizations, and that runs in one single account and region for your entire organization. And then you have some config there, like being like turning on SNS topics and that kind of thing. So that the config of the administrator account should be done with the Terraform module that we've created, and there we have flags to turn all that stuff on and deploy that, etc. Like as you're showing right there, so like SNS topics, and maybe there aren't all that many flags, but certainly SNS topics is one of them. So then once you have that deployed, you then run the turf tool, and what that will do is it will iterate all of the accounts in all of the regions that are enabled in all of your accounts, and turn on GuardDuty in those regions and point them at the administrator account that you created with the Terraform module, and it will take all of its config and report all of its findings to that centralized account. Hopefully that's clear.
Okay, yeah, that's clear. Now, the one thing that I'm a little hung up on is that you deploy GuardDuty to a centralized security account in one region, but then when you run turf, the last thing you just said, is it running through all enabled AWS regions to enable all of them to have GuardDuty running on them?
It is.
Okay.
Yes.
And then that's just like best practice, even if you're not like actually actively running anything in those accounts or in those regions.
If you actually look at the AWS like foundational security best practices, as well as the CIS benchmark for foundational security best practices, they both require that GuardDuty be running in every region that is enabled in your accounts.
Okay.
So, and that the rub there is that even if you're only using a very small number of regions, there are 16 core regions in AWS that cannot be disabled.
Disabled. I looked into that. That's a real pain.
It
It's
is.
annoying.
And
if
you
you're
find the
using-
same thing.
And if you're
Sorry,
using Security Hub with the CIS benchmarks enabled, it's going to nag at you if you don't enable it everywhere. And that's the final rub kind of to that.
Yeah, and actually the same thing that we're talking about, if you scroll up a little bit in turf right there that you're on there, we have the same thing for Security Hub to do it's not that one, it's the one above that. That's is enabling, nope, the next whole section up. Yep, that one. So we have the same principle there for Security Hub, where you have to enable it in or run it in all the enabled regions. And then I think it's also above this, but we also have the same thing for AWS config, which we do that through a module. So, but you also have the same problem with AWS config, that it has to be deployed in every enabled region in every account in your organization.
Have you noticed a big cost increase if you're running it in those regions, if you actually don't have any workloads in those regions, or is it just like you got to check the box because they want you to check the box?
You got to check the box if you want those security standards done. But I think it's like, to run the entire baseline, it's a few $100 a month, basically, like to just run this, if you're not running a ton of like custom rules or anything along those lines. But if I don't know, I found that the companies that are concerned about the security and compliance checkbox don't generally care how much it costs. They want it because they can put that. It's like a requirement to do business. Like if you have HIPAA requirements or PCI requirements or whatever, like you can't get away with not doing it. So this is what the standard says, so you have to do what the standard says, kind of thing.
Okay.
Yeah.
Now, one quick question, last question. It
course.
seems like GuardDuty has a bunch of resources. The Terraform provider, AWS Terraform provider, has a bunch of resources that could accomplish what Turf is doing, but you'd probably need to loop through and you can't loop through providers. You would need to specify each region individually to enable it.
Yeah, it's more than that. So they may have just released something, but when we wrote this, like, a month or so ago, a month and a half ago or whatever, setting the organizational level GuardDuty administrator account as well as organizational level Security Hub account was not supported by the Terraform provider. So the only way you could do that was through the API. And that's important because if you create another account, that new account will automatically be opted in to Security Hub and GuardDuty and all of those types of things. So,
Okay.
So that's why we wanted to be able to turn it on at the organizational level. So it just because the other way of doing it has to do with you basically, it's an invite system. So the administrator account invites the other account, and then you have to accept it. And those aren't can't be done in a single transaction. It's you have to do multiple levels of apply then to be able to do that. And it turns out to be a nightmare to try to manage that through Terraform. So we went through.
Depend on local exec hacks.
Yeah, exactly.
Yeah.
And then you have to do a local exec hack to call out to AWS CLI to basically accept that. So we tried every possible way not to write a custom CLI to do this, but kept getting backed into corners where this was the only way to actually achieve it sanely.
They might have updated the resources to do this, but this does still seem like it's actually might be the better way to do it because of the fact that I think you would get into the rub of you have to specify all the regions that are enabled.
That's actually what we do for config. So I can probably, I need to upstream it. So I have a component that I've developed for config for 2 customers now. I'll actually upstream it to the component library. And what it does is it actually uses code generation. So it makes a call. There's 2 modules. The first module you apply, it makes a call to the AWS APIs, determines a list of all the enabled regions in your accounts, and then it generates basically a stub provider for every one of those, and then you can apply the config module, which would then it applies it in every region across every every account, that kind of thing. It's such a painful, it's a nightmare to make it work,
yeah.
But that was the only way I could make that one work as well.
No,
so
it makes sense. I got you.
Okay,
I'll stop taking everybody's time. This sounds good.
Public service announcement, T-1 minute for the Starship launch from SpaceX.
Oh, wow.
Okay.
Oh, wow.
I can give insight on this one. So Eric, if you go to the invite acceptor at the left here, Security Hub invite. So this one. So this is fairly new, 2 weeks ago. So this one can solve some of the turf that's doing, but this is a special case.
Well, the other problem is that the invite comes from one account, and then the invite acceptance comes from a different account. So you actually have to run them in different Terraform applies, or you have to do a bunch of provider hacks to do roles to assume across the various accounts and all of those kind of things. So even with this, it's still not that clean, but this is definitely better than it was, a few weeks ago, for sure.
I agree.
Yeah. So unfortunately, this was messy to develop. I kept running headfirst into walls.
Very cool. Let's see what the next question is here that we had. How do you manage the S3 state backend configuration for multiple components? And when Cloud Posse talks about components, we're talking about root modules. So it's conventional for us to deploy very few Terraform state backends, at least one, but not too many more than one. And how do you manage the configuration for that? Let's see. So one of the problems, the Terraform data or Terraform backend S3 config. So actually, I think I'll just go to Cloud Posse Terraform state. All right. So this is the module that he's using and he's talking about. This is a standard backend definition that points to the bucket that you've created. The problem is that these things here don't support any kinds of interpolation. So they have to be static. So what Cloud Posse does is we generate the backend configuration as a tf.json file. tf.json are loaded just like regular Terraform code. And then what we do is we set the key prefix on this backend resource. So key or maybe this module hasn't been updated with the latest terraform-docs, so we don't link out to... Yeah, it hasn't been updated with the resource links here, so I'm a little bit slow to explain this one. Matt Calhoun, you want to explain anything more on this, or? I don't think we have an example of a generated one that is public. Terraform S3 backend key prefix.
While you're looking, this is Jeff Dyke. But anyway, I was just curious, are you basically just using a template file with JSON? And so you can use variable interpolation for that?
Well, kind of, but it's JSON. So we can just use a native HCL construct, a native JSON construct.
Yeah.
And do that. So we don't do templating of JSON. We just generate JSON. So we have a JSON generator. So the way we do that is in Cloud Posse Atmos. So Atmos is kind of our tool for combining all other tools. We use it to kind of tie our framework together. One of those things, and we have a module in here in Atmos for Terraform. And here's the backend module, and here's how we do a generator for that, basically. So what you're looking at here is HCL code, but we're using a program called Variant. So Variant is a CLI by Yusuke or Momoshu, and it allows you to define a workflow using HCL. And we use this to then generate our backend configuration. So we just generate this file backend.tf.json. And we set the workspace key prefix depending on the workspace we're using. So we can use the same state backend for as many environments as we want, just by setting the workspace key prefix to ensure that it's unique. Any questions on generating Terraform state backend configurations or why we do it?
Wish I looked at this code a couple of weeks ago. I spent a bunch of time writing Python to import state from some GCP projects that I had to start from, like service host projects.
Yeah, exactly. Python is just it would be another way of accomplishing ultimately the same thing. I was just gonna see if I had a good example here quickly to bring up, but yeah, it's taking too long.
I asked a similar question on this, so that's why I keep jumping in. I'm just looking to move from TerraGrunt to Terraform.
All right.
So in TerraGrunt, there is a very handy function which is just, now I'm gonna forget the name of it, of course, which allows you to go up, path relative to include.
Yeah.
So that, since the Terraform blocks are in plain.hcl, I can use that function in the middle. And, I end up having tons of, or a lot of state files. And originally my thought was just to, when I first started doing this a few years ago, was just to reduce the blast radius, as it's called. And so that'll direct, no matter what directory or component or module I'm in, it'll always go to the right bucket with the right key. And that's kind of the solution that I was trying to that I was asking about, and I don't mean to stomp on, I think his name was Brett's question. Go back to the Zoom channel here, but anyway, that's kind of I thought that was very handy for simply doing this. And it seems like I could do it mostly with stacks also.
Yeah, so this is what's such a it's a little bit mind warping to think about it, and we've talked about it a little bit on other calls. So if you go back to YouTube and check out some, I think we talk about the YAML stack configuration. So I think it's important to think about the separation of Terraform code with Terraform configuration as two separate beasts. And what we've done in the stack configuration is here's like how we define our stack configuration. So we have, this is all the configuration period for an environment. And in here, we're defining the backend that we want to use. And this backend is saying we want to use an S3 backend, and then we specify all the keys. The structure here that I'm specifying, that is exactly the same structure that just needs to be written to a backend.tf.json file. So that's why what we do is we have something that takes, so we have one configuration file that defines all of our configuration for Terraform, for Helm file, for Docker, for everything we want to do in one place. And then we have different tools that take that configuration and generate code as we need it to. And it's like this generator pattern that we're kind of basing it on. So in this case, we commit this JSON file for the backend that was generated to source control. That way, it still is totally compatible with GitOps and stuff like that. Unfortunately, I am embarrassed that we don't still have more of the documentation up for this. We are working on the documentation for this and publishing it up. Unfortunately, we've only come through these 3 sections here that are starting to explain how it all works. But our tutorials on how to set this stuff up are still forthcoming. There's a lot of fundamentals and concepts that we still need to introduce to explain how it works. And it's very unconventional from how the rest of the Terraform community is using Terraform. But I think it'll make sense once you see it.
Excellent.
Yeah.
All right. Sorry. Yeah, sorry.
That does make sense. Thank you.
Yeah, sorry. I didn't have a better explanation than that right now. We'll have in the next, keep posted. Probably within the next 1 to 2 months, we'll finally have the stack documentation up there and explaining how to use that. Matt Gowie on the call here. He's actually working on it. We also, Matt, we have to as soon as we merge your pull request on GeoDesic, which will probably be this week, we got to announce that. So we finally have some good documentation explaining GeoDesic, which is one of the building blocks you need to understand in our overall strategy of what we do. And this is, I'm so excited about this documentation here coming out. All right. Yeah, I'm just going to digress and move on to the next question here. Is the new HashiCorp Kubernetes provider ready for prime time? So HashiCorp, I believe, actually has 2 Kubernetes providers, and one was entirely redesigned. I haven't yet checked out the new Kubernetes provider. Anybody using it yet?
The alpha provider?
I don't know if it's alpha anymore. I think they might have not made it alpha.
It's beta. They had a fancy blog post announcing it, and it was beta.
Oh, okay. So it's graduated from alpha to beta.
If that's what we're talking about,
Sure. That is.
It's still alpha, I think.
Okay, yeah, it is still alpha. So I guess, yeah, as things go and the naming conventions go, I guess it's not ready for prime time yet.
I think this is confusing because they did release a version 2 provider that broke configuration, but then that's not this.
Yeah.
Because I remember, Vlad, you brought up the fact that the new provider, which is this alpha provider, allows you to just specify a YAML manifest, right? Or I guess
raw JSON, yeah.
Yeah, raw JSON, which would be really sweet. That'd be awesome. I hope that this lands soon. But then version 2 provider doesn't support that. So it's like they have multiple streams going at the same time, and that kind of confuses everything.
Can anyone add any context on this?
I think the alpha support all Kubernetes resources actually. So it's integration between the Kubernetes API and the Terraform. So there is a difference actually between the two. Because the current one is only supported a subset of Kubernetes. Yeah.
Yeah.
So they do it like they did with AWS. So you see on the new one.
Yeah.
I think I resumed this. I explained this a couple calls ago. So with the normal provider, they painted themselves into a corner. Remember how they weren't supporting stable resources, so they weren't supporting stuff like ingress and things like that.
Yeah.
They only wanted to support stuff like that, and Kubernetes changed massively. CRDs became a thing. People really want to manage CRDs from Terraform. And the new alpha provider is a total rewrite, a total idea, a totally different idea about how to go implementing a Kubernetes provider. That doesn't mean that the current Kubernetes provider that they released V2 for is bad. It just doesn't support as many resources, and it's more limiting in some ways.
Yeah. I think the difference might be
CRDs are the main difference.
Yeah, so really you're just specifying a manifest. So if we look at the documentation before, there was a primitive for each, there was a resource type for every kind of Kubernetes resource, which made it not work at all for CRDs, because there's no way they're going to implement the custom resource for all the custom resources. So in the new one, it's literally just a manifest, I guess, that you're specifying the raw data structure.
And I do think both of them will be maintained. Like, I don't know what HashiCorp is thinking of this, but it would make sense to maintain the normal Kubernetes provider for a more opinionated way of dealing only with Kubernetes official objects like deployment, service, whatever, and then have the alpha provider or whatever they're gonna name it for more custom stuff like CRDs and things like that.
Yeah. I think that makes sense that they should continue maintaining both. All right. Any questions on that? All right, Andrew. Well, we only have 2 minutes left. Andrew, should we just bring your question up next week?
Yes, sure. That's fine. Okay.
I think so. It's a hard one to answer. Yeah, let's get to the rest of the questions next week. We'll wrap it up for today. I think that was a great session. We covered a lot of questions this week for sure. Well, thanks everyone for joining. Please do subscribe to our YouTube channel by heading over to youtube.com/c/cloudposse and catch up on some old office hours sessions that we have there. If you're interested in booking a session with Cloud Posse, you can always head over to cloudposse.com/quiz to book a session with me, and I look forward to talking with you there. See everyone, same place, same time next week. Make sure to register by going to cloudposse.com/officehours. Office hours. Again, that's cloudposse.com/office hours. Take care.
Bye-bye.
Bye-bye.
Thanks.